Welcome, everybody, and thanks for joining us today. I'm Doug Denny, the Director of Technical Marketing for our dedicated infrastructure business unit here at Rackspace. And we're joined here today by our guest, Adrian San Miguel, who I'll introduce here in just a moment. Rackspace has hosted the Cloud Office Hours series for a couple of years now, where our friends bring experts to the table to talk about all things cloud and how we're seeing our customers utilize cloud to create great outcomes. But through that process, we've had lots of customers reach out and ask us what role does dedicated infrastructure have in this world? And so we spun up this deep dive series to tackle these sorts of questions. We host these sessions on the second, third, and fourth Wednesday of every month. And each month we focus on a different theme, such as security or performance or managing costs. In each session, we'll talk about real-world use cases with experts such as solution architects or product managers or product engineers, and we'll give you the opportunity to download something useful like a reference architecture that we use to support the discussion. You can actually download the supporting reference architectures or reports at rackspace.com/deepdive during or after the show. If you have questions, if you're viewing live, you can use the Google Q&A functionality to submit them to us. And on the back half of the show, we'll compile the questions and answer them as many as we can before we run out of time. If you watch on demand, you can email your questions to customercare@rackspace.com, which goes to me and my team, and we'll be sure to get back to you in a timely manner. So with no further ado, I want to introduce our guest today, Adrian San Miguel. Before we highlight what you're going to talk about today, Adrian, tell us a bit about how long have you been at the Rackspace?
I've been at Rackspace for just under 2 years now and came from a very technical architecture background, having worked in various software companies here in Austin, but doing my time serving as a bench tech at a small tire shop in South Texas, up until my current role where I'm an enterprise support engineer here with Rackspace for both Linux and Windows applications.
Very cool. And so, as an enterprise support tech, you support a very interesting customer who we're not going to name today, but they have an interesting story. They've been with us for several years, and they've evolved into what we call a hybrid customer here using our Rack Connect local solution. So that's pretty much what Adrian's here to tell us about, right? So he's been very, very involved in this account over the last couple of years. Tell me how long have they been with us, roughly?
They're just about to hit their 8th year anniversary and have truly evolved from let's try a couple servers, see if Rackspace is a good type of fit for us, to being one of the largest hybrid customers, as you stated, consuming a boatload of services on our dedicated space, but also making use of Rack Connect, as you mentioned, to evolve into the cloud space, where almost 60% of their bulk processing happens today.
Yeah. Okay. Awesome. And tell me, without exposing too much info, what do they do roughly?
Well, long story short, they get people together. They provide a common meeting place where folks can talk about things that are important to them, stuff like employment, career opportunity, stuff about bettering the individual. And what my client does is they take this data and they munge it on the back end and help optimize these type of searches, help optimize these type of queries and what people are looking to do, what they want to do, and what's kind of falling off the map. That way, for somebody like you or I were to go to their website and consume the service, we know exactly what's relevant and could, say, spend the next 6 to 12 months working on our OpenStack lineage as opposed to spending those 6 to 12 months working on something like Python, which is great and all to know, but not exactly one of those top-tier demands that people are looking for.
Okay, awesome. And it's safe to say then, too, that their infrastructure has evolved with us over time, but that's also representative of how the customer themselves has evolved the way they write and deploy software. Is that a fair statement?
Yeah, that's a very fair statement. Back towards the beginning of their tenure, it was still very manual, very pizza box, very brick and mortar, where if they had a need, they would install a handful of servers to facilitate that need, stand up a traditional load balancer so that they can effectively manage and make them redundant. Now they've come into a space where if they have a need, they can spin up exactly however many of whatever type of server they need, tear it down after they're done using it, and on the back end as well, evolving from a very static, very slow-growing type of data footprint to something that needs to be able to expand on demand on the fly.
Okay. And so as they've evolved, both in their own requirements, but also their own ability to develop and deploy software, that has changed the way they need to consume everything from whether it be storage or compute demands from us for networking performance and capabilities, right? All of these things.
Yeah, that's a very, very fair statement. As they become leaner and more agile, we as the company have to also provide them a way that they can work in a way that's conducive to their workflow. If it was a traditional step-by-step development to test, development to staging, near prod production type of environment, we could facilitate that need. But as their continuous integration, continuous deployment, they're to the point where they deploy an entire fleet of servers in one shot, and the next time they need to do another code deployment, they stand something else and tear the old one down, taking the lessons learned and moving forward.
Well, this is great, right? And we're going to get more specific here as we move through the conversation. But I like this customer story because this is representative of something that I see a lot as someone who works with sales. This is a customer that has been with us the better part of 8 years, and we have worked with them as they have evolved, and it's been a journey, right? A journey from this pure dedicated type of deployment, and as they've evolved, we've evolved alongside them and helped them reach this hybrid state. And I think this is good to talk about, right? Because we're going to really get into the meat of like how this occurs with our customers, which is also a good story about how this occurs in the real world, right? I've seen a lot of RFPs out there where a customer has a physical data center, and the RFP, is 50 pages long, but it basically says, "Make my data center cloud." and what we know is that that's not a one-step move. That's an actual process that is usually collaborative between the provider and the customer. And I think we're going to get into what that actually means specifically today when we talk to this customer's use case. So, no further ado, let's expand upon some of the highlights that we just recapped. You mentioned that they were 100% physical in the beginning when they came to us.
Yeah, 100% physical. Linux OS serving for Apache Web Helpers, Tomcat Java servers, and a traditional Big Iron MySQL database backend. I'm sorry, MS SQL backend.
Okay, got it. And I imagine they were just throwing more servers at the app tier and trying to figure out how to scale the DB tier.
That's exactly what it was. Little things like cluster size configuration, making sure that file systems were sector aligned, making sure that when you add one server in to solve a 10% overcapacity range, that you plan ahead 6 weeks when you're going to need another one. These are the type of things that, as this customer grew with us, it became a lot more sophisticated and a lot more cognizant of what their trend utilization was. And without that tight relationship with the account team, I don't think that could have been possible.
Yeah. And I imagine then though, even that resulted in a lot of tickets, I bet.
Yeah, lots of tickets, lots of communication, lots of late night phone calls to answer the what ifs, to help really quell the fears as we were helping them through this transition, where at one point they were waiting X number of days for a new server to be built as opposed to X number of minutes for an entire new fleet of servers to be spun up. Okay.
And so you're hinting at some of the challenges they had. Just in general, what more do we have in terms of challenges? What were they?
Sure. One of the big challenges that they had is we at Rackspace do a very good job of analyzing what our constituents may want as far as a hardware footprint. That being said, one size sometimes doesn't fit all. A lot of this customer's cases, they needed lots of CPU power, not a lot of memory because they were more CPU bound.
Okay.
Unfortunately, with some of the hardware offerings that we had on the table at the time, we just couldn't meet those needs. It was something along the lines of a 2x4 core server with 128 gig of RAM, where what they really needed was a 2x8 core server and say 64 gig of RAM.
Yeah.
Yes, they could start doing stuff like Docker and other containerization or virtualization footprints to make the most of that, but at that point you start hitting a break-even situation where you're putting 3 servers onto one. There's got to be a faster, more scalable, more robust way to do this instead of still having to wait for that hardware to arrive.
That is one of the admitted downsides of sort of the physical world of physical compute, is that you're sort of bound to the form factor of the server. You could pull RAM out of the chassis, but generally from a cost perspective, that doesn't get you a whole lot of utility.
No, it doesn't.
So it sounds like they needed compute in increments that were actually smaller for a piece of their application than what physical gear actually allowed them to consume, right? It's very cloud.
Yeah, that's very cloud-like at its inception. That being said, there were still a lot of instances where, say, a back-end data warehouse server, a key management server, for example, needed a huge CPU footprint, a huge memory footprint that something ephemeral like cloud really wouldn't solve for. So as they began to grow, we started doing some use case situations, saying, hey, what feels more cloudy as opposed to what doesn't? What do we need to potentially provide a path for you to grow and scale and be happy and do the things that you really want to do, instead of having to re-engineer your application to make it fit what we've got with you.
Okay. And just in general terms of growth, I mean, you don't have to cite metrics, but I mean, how often were they adding capacity with us?
I'd say every 6 weeks it was another 10% increase, another handful of servers, another handful of storage, either on a shared model or local attached storage, depending on the use case. There was actually a point where almost every 9 to 10 weeks we're adding in another switch to facilitate 10 gig needs for the customer.
Okay. Okay. Great. And so that you hinted at storage, then, and I know that's its own sort of story in itself. Let's talk about storage. They began their life with us with local storage running in the servers themselves. Is that correct?
Yeah, that's correct. A lot of the stuff was local storage to the server, set up very basically in a RAID 1, RAID 10, RAID 5 in some instances. And as they grew, it became very difficult to put the 9th disk into a server that had only 8 slots. It became very difficult to get that extra oomph that we needed, for example, like in a data warehouse server example, where you need more storage as opposed to speed, and you can only go up to X at the time with the storage footprint into the server. So that evolved them into a direct attach type situation, storage appliance where they could consume as much storage as they needed to many servers that needed that much storage. And it got to the point where even that rate of change was so high that, while a good idea, it just wasn't good enough to keep up with their constant demands.
Okay. Okay. Great. And so you mentioned they had local storage. They evolved to a shared SAN solution, which I'm a big fan of here, just due to the simplicity of how you consume it. But their storage needs continue to evolve, right, to the point where we actually found that there was some benefits to giving them an actual dedicated array or dedicated arrays. Is that correct?
Yeah, that's absolutely correct. They hit the break-even point where it was no longer as cost-effective to go on a utility model, where as you have performance on demand and can scale and grow on demand without having to be constrained into the utility model. Okay. It just made a lot more sense to them to say, preemptively add 2 or 3 shells of a certain form factor. That way, as their storage needs evolve, they can cut the need to expand storage off at the pass by immediately inserting disk upon need.
Okay. Okay. And let me ask you this. So when I look at when I think about the different systems that make up their deployment, which systems are consumers of that SAN storage? Is it the physical servers today, or is it the servers in the cloud? Obviously, the database servers. How does that work?
Well, yeah, the database servers are clustered. There's several different SQL cluster instances that are running back there. Some of them are making use of it in a traditional data archive, data warehouse type format, where they need space and not necessarily speed. In other instances, there's blinding speed requirements that have been effectively set up with multiple layers of tiering. That way, the hot data stays at the very top, somewhat important stays at the middle, and then anything that's rarely accessed gets thrown down to the bottom. And if it needs to, it'll be weighed and brought up. It's a constant balancing act on the array. That way, they get the performance they need for the database service for something highly transactional, say their logs, their transaction log, their stored procedures, etc. And the actual data files live in the fastest storage, and everything else, like a seldom used query or seldom used data set, is constantly kept on the bottom. That way, cycles aren't spent bringing that lower stuff up to the top.
Awesome. Okay, then that's useful. I think this is interesting to highlight because we see this fits a common pattern that we see at Rackspace that I don't think gets as much attention out in industry, because it kind of breaks this bifurcation that everyone it just makes it's easier for us to wrap our sort of pea brains around if things are either cloud or old world, right?
Yeah.
But this customer highlights a pattern that we're very familiar with here, where you see the application tier sort of on this trajectory that is increasingly cloud native, right, as the software evolves that the customer is authoring. But in this customer's use case, due to the nature of their data, we're actually seeing that track in the other direction, where they're consuming more due to need of technologies like dedicated SAN, right? And dedicated SAN, like EMC, VNX platforms, are not typically associated with cloud architecture. All right. It's just they don't typically go hand in hand if you pay attention to like what's going on Twitter, right? But when you pay attention to what our customers need, like this is like we do. This is very common. We
Yeah,
see
absolutely.
all the time, right? Okay. So it's just good to highlight this stuff because I think this is at the essence of what our hybrid story means when we talk about Rack Connect Local and bridging the public cloud with the world of dedicated infrastructure. These are the sorts of problems you can solve when you don't make this a binary discussion and you consider how to intertwine the two into a holistic solution. So that was me sort of pitching this. Thank you for suffering through it. But again, hopefully as we keep moving through this conversation, we'll continue to shed light on like why that's a thing and why people should care.
Yeah, absolutely.
Just to talk more about their overall architecture, you mentioned they run on SQL Server, Microsoft SQL Server on physical hardware today. Is that correct?
Yes, that's correct.
And what sort of capabilities are they taking advantage of by using dedicated SQL Server?
Specifically, they're able to do a lot of cool things like always-on clustering. They're able to use HA clustering. They're making use of NT availability groups. They're making use of a lot of things that necessarily lend themselves better to physical hardware, such as high memory count, high CPU count, and the availability and need for a heartbeat private network to make sure that in the event that primary fails, the heartbeat isn't registering. You have a third mechanism in which that the cluster can validate that it's healthy and process data in the event of 2 catastrophic failures.
Okay. Very cool. That's all big stuff, right? I mean, I like Cassandra. But man, if I'm heavily invested in SQL Server and I want the nice things that I get with SQL Server, again, especially the advanced stuff, right? That really benefits from like shared storage or a common storage platform between the nodes, right? I think.
Yeah, absolutely. The nicer the data tier, the more possibilities that get opened up. For example, in this scenario, if it was Cassandra, if it was Hadoop, if it was MySQL/Galera, you have the storage layer taken care of. That extrapolates that need to worry about making sure that the storage is equal across all the nodes. You have one shared fabric that is robust and resilient that all of your workers can connect to, at which point they're free to work and not have to worry about local storage ever going out on these guys.
Got it. Okay, cool. Very cool. And then we're going to kind of dive into the Rack Connect conversation, but let's talk a bit about how they consume cloud today. And so they have public cloud, which isn't. We don't really expand upon that a lot in the reference architecture diagram. We have cloud sort of placed there, but we don't unpack it, right? So how are they using cloud specifically?
They're using just about every flavor that we offer. General performance for less top tier, for example, like a WordPress site or blog development needs, etc. The top tier stuff is going to be using the compute I/O and the compute I/O and the memory optimized flavors for the different needs, from running Apache Solr, running Redis, Hadoop, stuff of that sort. We have met every one of their needs with the base CPU footprint, the base memory footprint, and the availability with cloud block storage in the cloud lets them tear down those nodes when they need to redeploy a code upgrade, and swing the data volume right back up to it. So it's essentially picking up exactly where it left off with the new code base running on it.
Okay. And those workloads that run in the cloud, do they have data dependency on the physical infrastructure, I assume, that lives in the physical world at Rackspace?
They sure do. They hand off a lot of the search requests, a lot of the different app things that happen go down to physical workers, as we did see on the reference diagram. Depending on the workload that's being requested, that group of servers takes the query and passes it directly down to the SQL backend, and where on the way back, it is cached on those servers to further isolate the need from making repeated queries back to the SQL backend for stuff that people already want to know about anyway.
Okay, very cool. And just a note for folks, I'm going to take a minute to do some housekeeping. So one reminder that if you have questions that you want the team to address, please use the Google Q&A feature of the Hangout if you're watching live to submit any questions our way. Two, we recognize that this architecture side is very busy because it represents a very large customer of ours. So if you're having trouble seeing it, please, you should right here from within the page that you're watching be able to submit the form to actually download the reference architecture, and that'll give you some insight into what exactly this customer has deployed with us. A derivative work based on what this customer has deployed with us. So then jumping back into the content here. So we know over the roughly 8-year span of life this customer's had with us, they have continued to evolve their cloud competency. So let's just talk a bit about that. It sounds
Sure.
like they're using AWS for some other functions. Is that true?
Yes, that's true. They're using AWS for various test and dev sandboxes. They also have some prod development happening there as well. And over the last 6 to 8 months, there was a very real need for them to connect what their developers are doing in AWS over to what people in production are doing in Rackspace, and we were able to get them connected. And now any of their Rackspace footprint can traverse a VPN tunnel and hit AWS and vice versa. We're providing the common SQL backend to facilitate all of their needs now.
Okay. That's very cool, and we should talk to them about Rack Connect Global.
We already had that conversation.
Awesome, good work. And then, how I know you weren't necessarily around when they broached the topic of cloud with us, but do you have any insight into how that sort of began? You talked about the granularity of compute, but any other stuff you want to share?
Yeah, when they were first starting to toe the water into wanting to become more cloudy, there were a lot of questions. How do we know it's secure? How do we know that it really scales? How do we keep folks that we don't want into our environment out? How do we run it efficiently? Who's going to manage it? Is that going to be Rackspace all alone with our intervention? Is that going to be just us and we call Rackspace when we need you? Those are the type of things that were being asked. And as the product became more mature and they became more mature, we found ourselves less and less hands-on into their cloud, where they only really get a hold of us if they can't figure something out or they've exhausted each of their troubleshooting needs, and it's something that we need to immediately jump on.
That's really cool. Okay, so as they've become more over time too, they've not only have they advanced their cloud capabilities, but they've also sort of advanced their comfort level with navigating through our systems and our portfolio of solutions here at Rackspace.
Yeah, absolutely. They're incredibly competent with the portfolio. They're incredibly cloud savvy in the sense that they know that if they can't figure the answer and I can't figure the answer pretty quickly, we can get the right people on the phone or on a ticket or in an email thread, and it'll get done rather quickly.
Okay, awesome. And then let's dive a little bit into Rack Connect then too, because they're not just consuming the cloud and physical infrastructure, they're consuming the marriage of those two things, which is facilitated by Rack Connect Local, right? So tell me a bit about like what it means to use Rack Connect Local versus just using those things independently.
Sure. In a nutshell, Rack Connect Local is an L2 extension, layer 2 extension of the dedicated footprint down here where SQL lives and dedicated storage and dedicated 10 gig type of equipment, and up into the cloud where their cloud assets live. It is an L2 bridge that essentially extends the network from dedicated to cloud so that the cloud apps and cloud servers can make their calls directly into the back end in a very secure, scalable, and extremely flexible configuration. If they want to set QoS policies for VLAN XYZ down to the SQL backend, they can do that and make it take more priority as opposed to, say, the Redis cluster that would only ever need to talk to itself and rarely anything else. The flexibility of what you can and can't do is pretty well defined, and we constantly find ourselves in exercises with, hey, we would really, really like to do this, or development would love to see this type of thing happen. And it's that type of conversation that helps drive our conversation with the product teams to ensure that the product keeps maturing, that the constituency is happy with what we have, and that it's constantly evolving. If we stayed stagnant, not a lot of people would probably be using it.
Yeah, and so this is what's great about this customer is they're my understanding that is they're like, thanks for Rack Connect version 2. We're pushing the limits. What do you got for us now, right? So they're now participating in an evolution from Rack Connect version 2 to Rack Connect version 3. And actually, one more timeout. So just to note, our friends Alan and Drew, who run the Cloud Office Hours, have already covered Rack Connect version 3 in exquisite detail. So again, those of you who just really want to get into the nuts and bolts of that, just like last week, I will link to that session in the post blog for this show. But I'm sorry, I couldn't help myself. We're going to talk about Rack Connect Local a little bit in this show because this customer story was just so intriguing to me. I couldn't leave it alone. So we'll dive back in. But how is this customer benefiting from Rack Connect v3? Like, just at the high level, what is Rack Connect v3 bringing, and how is that directly impacting this customer's use case?
Sure. Specifically, one of the big reasons why they're interested in v3 is the concept of the single tenant gateway, where that L2 connection from the dedicated segment to the cloud section has a termination point in which advanced stuff like even further granularity with network control policies, even further granularity with firewalling and security protocol, QoS gets ramped up to the next level, and we even have the capability to give them 10, 20, 40, 60, 80 gigabit throughput to their cloud should they choose to do so. They were hitting a point of contention on the edge device. Could you bring up the architect slide real quick?
Yep, give us 1 second to bring
Sure.
that up.
I can speak to this pretty quickly.
Sometimes it takes a minute.
No worries. Okay, so right here off to the right of the F5 on the diagram, this for logical representation is the edge going off to the Rack Connect V2 and the V3 segments. The interface is going to the V2 segment. We're hitting the point of contention where even with port channeling and bonding and LACP type trickeration happening on the network side, we just weren't doing good enough. They were almost 90% saturated at all times. Didn't matter the time of day or night. There was just that much chatter going on in between the two segments. So with the evolution of Rack Connect V3 came the ability to get rid of bonding, as we know it today, and start putting in intelligent 10 gig capabilities to these single tenant gateways that serve as almost a proxy into the environment where it's dedicated bandwidth back to their edge device and can scale and grow with them whenever they want it, whenever they need it.
Okay. So for the simple folks like me who might be watching this too, the bottleneck wasn't so much in the physical equipment that lived in the rack in the physical universe. It was in the sort of the provider layer glue that we implemented to bridge the cloud networking world and the physical networking together. Right? We'd reached the limits of what that could sustain.
Yeah, we reached essentially line speed for the solution. We hit the max.
Okay, and so Rack Connect V3, Rack Connect Local V3, was an architectural change, an architectural shift that allowed basically more GBs.
More GBs, all the GBs actually.
All of them. Okay, very cool. And again, I mean, as you can imagine, if your storage platform lives in the physical world and is so robust that it requires multiple nodes for data stores, and you're consuming in a fully dedicated array or arrays, leveraging storage tiers and pulling, and that data powers your app in the cloud, I don't think it's a surprise, right, that you require pretty robust interconnect in order to accommodate that use case. So, here's a good example of our customers sort of pushing us forward and evolving our platform.
Okay, sure, yeah, that's actually very accurate. As mentioned at the bottom of the art slide, the 10 gig local network switch was put in to facilitate that need. Yes, it's great that we can talk to our database servers and pull these queries across at 1 gig speed, but as they grow and get more complex and those links start getting more saturated, there has to be a way to continue to grow and facilitate those needs where if everybody were to ask at the same time, are we in a FIFO first in, first last type situation, or can we start doing some more intelligent thing like receipt size scaling and making use of 10 gig speeds to facilitate these requests? And as they grow and as they continue to grow, we see that, yes, this is the way that we need to go. Instead of growing horizontally, we need to start growing vertically and giving them room to grow into as opposed to growing with them. Yeah,
that makes sense. Have you ever had a customer call you up and say, I think I need less network performance?
Actually, one, and it was kind of a one-off, but we'll get into that later.
Okay, yeah, very low rate, one less. Okay, and then Rack Connect V3 also allowed them some additional utility from a security standpoint. Again, being careful not to expose any customer identifying properties, but tell me a bit about how they benefited from a security standpoint with Rack Connect V3.
It really, in a nutshell, helps them check the box. Is it single tenant, which is always a huge concern with folks going to the cloud. Various compliance requirements dictate single tenancy, or at least a very well-defined, walled-off environment. And going to V3 really does help that because it's truthfully single tenant infrastructure making use of public cloud, but carving out a nice little circle in which you get to play in. Will it help you get there? Absolutely. Is it a check the box, you automatically have it? No. That's where the architects and the account team come in, so we can help make that a reality by ensuring that only parties X, Y, and Z can access your server using intelligent things like RBAC, role-based access control, where only certain individuals with this job function can actually do things for you. and continue the conversation on from there. But just the simple fact that these things now exist and can be as broad or as narrow as they need to be, that's a huge win.
Okay. Well, and then does that imply to, as let's say, like if an F5 appliance is sort of the gateway device between the physical networking world and the cloud, does that mean that any sort of native F5 access control and policy tools that I have at my disposal are available for me to manage ingress and egress from the cloud to dedicated and vice versa?
Yeah, absolutely. That access is readily available through the My Rackspace portal, if I'm not mistaken. Everything down to changing QoS settings, changing who can talk to what, changing whether server A and segment B can talk to VLAN C. All of those things are literally at your disposal in the palm of your hand. You can be as granular or as permissive as you'd like.
Okay, and that's something we talked about in the first deep dive series, where a lot of times when you look at sort of cloud networking constructs, because they're geared for simplicity of consumption, they also, the compromise you make is that you don't always get the fine-grained controls over the outcomes that you get with a dedicated physical appliance, and that's, again, one of the big compromises you make when you view things through a binary lens of dedicated or cloud.
Mm-hmm.
But in the hybrid model, as we see here, this customer gets to benefit from the power and the flexibility of the dedicated physical appliances, but still reap the benefits of that power when they consume the cloud.
Yep, absolutely.
Okay, just want to make sure that's not lost on anyone. I do work in marketing, right? So, okay. And any other security stuff, or do you want to wrap up that part of the conversation?
I think we've touched all the points. The one good thing to remember that, of course, it is entirely up to the customer to go through and define those, but the account team is more than happy to walk through and have those discussions and bring in the right people in that type of situation where you want to get even more granular while not completely walling off the infrastructure. Those are conversations we have all the time.
Okay, very, very cool. Thank you.
Sure.
So I'm going to kind of summarize. Well, we'll summarize together kind of what we talked about today. I think this is I found this story to be really compelling because it really highlights, again, the idea that getting from the physical world to the cloud and achieving a hybrid architecture, or even going all the way to cloud, right? It really is a journey. It's not generally something where you flick a switch and it just happens magically. There's cases where you can crowbar something into the cloud and it operates, but it doesn't necessarily create the best outcomes. This highlights, again, that this is a multi-part journey that is still ongoing.
Yeah, absolutely. It's been a complex and at times very slow-going and painful, but at the end of the day, it's making sure that the customer is best equipped to make the best decisions for their business, making sure that they have the flexibility and don't feel like they're being strong-armed into a solution that doesn't fit, and also just to make sure that we as Rackspace enable our customers to do the things that they need to, want to, and are demanding that they have to be able to do.
Okay, great. And actually, this isn't really a summary, but let's just, as a note, their evolution is still ongoing, right? They're still trying to place more and more workloads into the public cloud. Is that fair?
Yes, that's actually very, very accurate. They did have a mandate, and they did let us know recently that rather soon they do have to have more of the workload in the cloud just because of the things that they've been able to do. They can continue to reduce some operating costs by getting rid of some of the physical servers that aren't exactly being used to their key potential, where inversely one app server, say, in the dedicated footprint can result to 10 more in the cloud that are capable of filling that need. It may not be as wide of a CPU footprint. It may not have as much memory. However, when you have 10 nodes replacing what one can do, other things into the discussion come economies of scale, reliability, high availability, load balancing, where, for example, in the dedicated side, if you have 20 app servers and you lose one, you're down to 1/20th capacity, where on the cloud side, if those 20 become 200, you lose 1 out of 200, that's a very different conversation.
Okay, very cool. And then as they become, although their application is evolving and increasingly cloud native over time, they are still reaping the benefits today of things like physical layer 7 aware application controllers, right, that benefit from wire speed, right? They're physical, they're not a virtual appliance.
Yeah, absolutely. I don't think that need will ever truly go away. There's just some things that, an F5 with 90 gigabit throughput, for example, just can't really be beat.
Yeah, That makes sense. And I think it's especially true in these use cases where you see application tier and data store tier like on divergent paths of their evolution, right? Well, that really then only amplifies the importance of networking performance when there's that much more chatter going on between these two tiers as the application continues to grow and evolve. And that brings me to another piece, which is that sometimes the economics and of like price to performance of dedicated arrays is still hard to beat once you reach a certain scale, right? Like storage economics for smaller volumes of storage with lower performance requirements generally win out in the cloud. But if you have a heavy IOP requirement and heavy storage requirements, this sort of proves that the customer found economic benefit of using dedicated technology to handle that piece.
Yeah, absolutely. It's a lot more easy and generally more flexible to scale for, say, 150,000 IOP requirement on a storage array in a dedicated space, whereas having to really do some thinking and having to do some capacity planning to get that much throughput available in the cloud. Here, this is on the dedicated side, it's one appliance or set of appliances for one customer that isn't potentially 100% contingent on having polite neighbors that aren't, for example, re-indexing their entirety of a SQL backend every hour. Here, if they wanted to do it, the only person they'd be hurting is themselves.
Right. Okay, awesome. And then finally, similarly, bare metal performance for databases, like that's a thing. Right?
Yeah, it's very much a thing. Depending on the footprint, sometimes it's not better to go into cloud. If you have, for example, 40 CPUs and a terabyte of RAM, that is going to be incredibly difficult to get virtualized and tuned properly in a cloud footprint. Whereas sometimes big iron just needs to be big iron.
Yeah. It's funny too, because with all these things you see with like evolution towards like an affinity towards like in-memory databases as well, that kind of stuff. It's like, well, I mean, at that point, if really what you're gaining out of the solution is access to memory, there's not a whole lot of value in like laying down overhead that gives you sort of like mobility, right? Well, but by definition, you want the memory. You don't need portability of that memory. It's ephemeral. So all the more reason why like access to dedicated hardware for certain bands of use cases still, and probably will for a long time, make a lot of sense. Any final thoughts from you before we dive into some of the questions?
Well, to your last point regarding in-memory, in-memory is great when your data set is small and your footprint is conducive to that.
Yeah.
If your average data set size, for example, just a SQL data file is 3 terabyte, you've already lost that argument.
Yeah.
And sometimes in-memory is great, but it also truly depends on the use case. Does it need to be static? Does it need to be able to persist so you lose a server? What is the rest of your application going to do if it loses that data temporarily in time?
Yeah, that makes a ton of sense. And I'll be honest, I kind of just wanted to use the term in memory. It's a good thing you're here to keep me on the rails.
That's what I'm here for.
Well, then let's dive into some questions real fast. I got a few. Let me pull them up.
Sure.
My mouse work. Okay, I've got quite a few.
All right.
Let's see. Here's a good one. Explain what LocalNet is again. How is this different from ServiceNet that I see in the diagram?
Sure. LocalNet, in a nutshell, is local truly and specific to the individual customer. This is their switch that they have purchased. This is nobody else on it, and is usually used for non-application specific traffic. In this particular use case, because it's a 10 gig robust and very scalable switch, it made sense to hook up all of their dedicated servers and the database backend to these switches so that they can make use of, to make use of 10 gig speed in a very scalable and stackable environment. Private net, for example, is specific to intra-database communications and stuff of that sort, Heartbeat.
Okay. And when we talk about these various nets at Rackspace, we kind of take it for granted because we're so used to talking about them, but those in the audience may not fully understand what that means. If I see represented in a logical diagram like ServiceNet, LocalNet, private net, does that mean that are those actually like physically separate networks? So I actually have a whole interface on a physical server chassis dedicated to connectivity to those different networks? Is that how that works?
Yes, that's 100% accurate. Different interfaces, completely separate networks, completely separate IP spaces, completely separate switch topology and endpoints.
Okay, okay, got it. Yeah, so these aren't like just because it's not like a virtual interface. So this is an actual. It's got a plug. There's an
Yep.
Ethernet cable. There's a different color cord. Okay, awesome,
Yep.
awesome. Um, and let's see here. Uh, this is a good question. We covered it a lot, but I want to. It's good to reiterate. So, what specifically drove this customer to place SQL in dedicated infrastructure instead of the public cloud? Was it performance, security, or all of the above? Let's just rehash that one more time.
Sure, all of the above.
Okay.
They had a giant footprint, ballpark around 17.5 terabyte of storage that needed to be available, needed to be
Okay.
scalable, and they needed to be fast.
Okay.
A lot of these things could be accomplished in the cloud, but the cost to benefit ratio was just grossly outweighed.
Okay. Okay. Fair enough. And then again, we didn't really dive into the architecture of the public cloud, but what services are running in the public cloud? We talked a bit about how they use it, but like tell me how they interact with the public cloud and how they deploy.
Sure, they have a ton of Apache worker nodes up there. They do have Apache Solr cluster running to load balance those nodes. They are making use of Elasticsearch and Redis, and they are also making use of Hadoop and Mongo as well up there to just further extrapolate the data as it comes in real time and feed it back to the workers and continue to pull analytics from that.
Okay. And since the question was asked, I'll take the opportunity to dig deeper.
Sure.
When they're releasing software to the cloud, are they doing that in like the classic cloudy way? Do they deploy a whole new fleet of instances and tear down the old one? Are they using configuration management, all that fun stuff?
They're actually doing both. They're using config management, bunch of different methodologies. They're using Chef to make sure that everything cooks properly after it's deployed, Ruby, Ansible, and Rackspace Knife to actually get the stuff deployed, and they are using the traditional cloudy way where, say they have 100 servers that are running Solr, for example. They spin up another 100 more, they verify they're good, they tear down the old one.
Okay, awesome. And then what workloads, if any, are run between AWS and the Rackspace hosted infrastructure? So you mentioned that AWS is largely dev and test for them today.
That's correct. A lot of the custom application code, those workloads are split in between the two. For example, proof of concept is proved out in AWS and brought over to the Rackspace side where it's allowed to cook a little bit longer, and once they're happy, they do the promotion of code from AWS over to Rackspace.
Okay, awesome. That's all the questions we have at this point, so I think what I'll go ahead and do is move into closing comments. I want to thank you for your time. I was really excited to talk about the scenario, so thanks for taking your time out of your busy day helping this customer continue to evolve to the cloud and help share with the audience, a bit of what we learned in helping a customer through this journey. So appreciate it.
Yeah, absolutely. My pleasure.
Cool. And then, by the way, you're not off the hook yet, because if there's any customer questions that come in through customercare@rackspace.com, I'm going to make sure that you're part of the helping me get those answered.
I'll be happy to do so.
Note to the audience, so please do use the form to download a very interesting reference architecture that was particularly hard to see on the Hangout, so please go ahead and fill that out. In addition, if you go to rackspace.com/deepdive, you'll be able to check out the schedule and see if there's any future sessions that you might be interested in attending and share those around with friends and colleagues. And finally, we'll be releasing a post blog, a wrap-up of the show within hopefully a few hours that you can then go drill into to review key points. So thanks again for attending. Looking forward to seeing you next time. Take care.
Thanks.